In this video we are going to talk about the fourth condition of conditional permutation, and that is alternating arrangement. How do we tackle such questions? Before we proceed, in our previous lesson we spoke about a third condition where object had specified positions, and then we said that when object should have a specific position, all you do is that the objects that are mentioned in the question, place them in their respective position. Then how many objects do you need to form the arrangement? In the previous example, or in the previous lesson, we had 5 letters to make the arrangement, and then 2 of these letters were selected, that is A and J. A was at the beginning and then J was at the end. So we needed extra 3 letters in between them, the beginning and the end, to form 5-letter arrangement. And then we had a total of 7 letters, and these 7 letters, 2 were already selected. 2 letters were already selected, therefore we're left with 5 letters, and these 5 letters, we were to select 3 letters out of the 5 letters to fill those 3 spaces in between the A and then J. And then we did that, and we were to take that permutation 3 out of 5 letters, and then we got a total of 60 ways. Here we only needed the number of ways that those 3 numbers could be filled, so you have to be very careful. Only the ways that the 3 letters can, the number of ways that the 3 letters can be arranged within those 2 letters, that's A and J. In this video we are going to talk about alternating arrangement. Now when we say something alternate, what we mean is that when a boy, let's say this is a boy, a girl will be here, and then a boy will be here, and then a girl will be here. That's what is meant by alternating. After a boy, a girl must come, a boy must not come. It's like not sitting together. It's like they must not be together, but this is quite different. So let's see how this is going to be done. Now, first of all, what you need to do is that whenever you have a question, when objects are different types or they alternate, the strategy is one type of object, arrange one type of object first. So what you need to do is that, let's say you have let's take a question actually to illustrate it. So in how many ways can 4 boys and 4 girls be arranged in a row so that they alternate? Now first of all, start with a boy. If a boy starts, so let's say there is a boy, so 1 2 3 4. What you do is that, how many spaces are left? A girl can be here. We have a girl, a boy, a girl, and then a girl. So we have 1 2 3 4. So you realize that when the boys are arranged, or when a boy starts, there are 4 spaces that the girl can also fill. So what you do is that you take 4 factorial of the boys, and then you multiply by 4 factorial of the spaces that the girls will fill. So there are 4 spaces and the girls are also 4, so we take 4 factorial. And then the next thing is that you also begin with girl. Here it's a boy, so you also begin with a girl. So when a girl also begins, then a boy will come, and a girl will come, and a boy will come, and a girl comes, and then also a boy comes. So 1 2 3, and then a girl comes, and then a boy also comes. So we have that they should alternate. So you realize that when girls also begin, there are 4 possible spaces that are left. And these 4 possible spaces, the boys must fill, and we have 4 boys. Too. So basically that is what. So you take another factorial, 4 factorial multiplied by 4 factorial. Then after that you add them, because they are mutually exclusive. So let's look at how this is done. So the condition is boys and girls alternate since they are equal numbers. So 2 patterns are possible. First of all, a boy will begin. When a boy begins, or a girl can begin. So here, this is what the condition: a boy can begin or a girl can begin. So you see, so the combining principle is going to be mutually exclusive. That is addition. So here, what you need to do is that, first of all, case 1, starting with a boy. If you start with a boy, it means that there are 4 possible spaces that will be left. So you start with a boy, you realize that boy, there's a boy here, a boy, and then a girl must come, a girl and then a boy. They are 4. So you take 4 factorial. You're going to take 4 factorial of the boys, and then also how many spaces are left. There are 4 spaces, and how many people are to fill these spaces? There are 4 girls. So you also take 4 factorial. You also take 4 factorial, and then you multiply the two because they are in a row. You multiply the two. Then the next case is that when a girl also begins, the same scenario. So when a girl begins, it means that you have 4 girls. You're going to take 4 factorial. You can be able to arrange 4 distinct girls in 4 factorial ways. So you take that. Now when the girls are also arranged, you realize that here there are also 4 spaces left. So there are 4 spaces left. So a boy will be here, a boy will be here, a boy will be here, a boy will be here. There are also 4 spaces left, and these 4 spaces too, we take factorial. How many ways can these 4 spaces be filled? We take 4 factorial. Then also after that we multiply the 2. So we multiply this one also. Then we add the 2 scenarios. We add the 2 scenarios where a girl started and then a boy started. So when the boy started, we had 576, and when a girl started, we had 576. Now since these two are mutually exclusive, we add them and then we get 1152 number of ways. So that is how to tackle conditions where the object must alternate. So thanks for watching, and let's meet in the next video. Bye.